Hey guys, this is a group A4 from X203. We're gonna start talking about the logical equivalence. So we're gonna start talking about what is actually logical equivalence. The compound proposition P and Q's are called logically equivalent if P, if and only if Q is tautology. Tautology means a compound proposition that is always true no matter what the truth value of the propositional value. So here's a proposition P and Q. And then notation for the logical equivalent is this.
To prove that if P, then Q is logically equivalent to not P or Q, we can use a truth table to do that. We define the truth values for P and Q. If P is true, we'll have Q as true. Then if P is true again, we'll have Q as false. That way, because we have to use all the combinations. Then let's try Q as true and Q as false. False, false. So that way we use all the combinations. False, 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 true, true, false, true, true. Next, we have to define not P to know the truth value of not P. So then we do not P. And so if it's not P, then it's false because it's true, false because it's true, true because it's false, true because it's false. And then we want to define not P or Q. Not P or Q. So not P. So we're looking at this right here, not P or Q. So it's true because Q is true. It's false because Q and not P is false. It's true because at least one of them is true. And it is true because not P is true. Now we want to look at if P then Q. So, if P, then Q, it is true for that because it is true, true. It is false because if P is true and Q is false, then that means the entire thing is false. And this is true, true. Now, to see that these two are logically equivalent, let me rewrite that. P if Q. We first look at P if P then Q, and then we look at this as well. We notice that this is true and this is true at the same time. False, false, true, true, and then true, true. So that proves that they are logically equivalent because they have the same truth value at each of their components.
So in the next example, we want to show that P or Q and R are equivalent to P or Q and P or R. So we're going to draw another truth table, but because we have three variables, P, Q, and R, we're going to have 2 to the third rows, which is 8 rows. And so we're going to make 3 columns to start, P, Q, and R. And we're going to have every combination of P, Q, and R possible between them. the first thing we want to do is work with this Q and R. So we first want to begin with Q and R, which is this right here, and we're going to be using these two columns. And it takes two trues to make it true, and everything else is a false. Next thing we want to do is focus on the whole left side of the logical equivalency sign. So we're going to be using P or Q and R. And we've already made Q and R. We're going to be using P. So it's P or Q and R. So we're going to have a true or true, true or false, true or false, true or false, false or true, and then we have false and false, false and false, and false and false. Next thing we want to focus on is the right side of the equation and the first parenthesis. So we're going to have P or Q. So we're going to be using this column and this column. So we're going to have true or true, true or true, true or false, true or false, false or true. So then we have a false and true, which gives you a true, false and false, and then another false and false. Next thing we want to focus on is P or R. So we're going to write P or R. And we're going to be focusing on this column and this column. So then we have true or true, true or false, true or true, true or false, false or true, false or false, false or true, and a false or false. And the next thing we want to focus on is this whole equation. And for space saving purposes, I'm just going to draw an arrow and put it here and give it a whole new column. So what we're going to be doing is focusing on this column and this column. So we're going to have true and true, which is a true, true and true, true and true, true and true, true and true, and then a true and false applies a false, false and true, gives you another false, and then a false and false gives you another false. And to show that they are logically equivalent, we need to show that this column and this column are the same in every single row. So here we have a true and true, 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 true and true, true and true, true and true, false and false, false and false, and false and false. Therefore they are logically equivalent.